Hello, my name is Dana Burns. I'm the founder and CEO of Boldmetrics. We're an enterprise software as a service AI solution based in Silicon Valley, California, and we service the retail industry, specifically the apparel industry. My talk today will be talking about artificial intelligence and its applications specifically within the retail industry, and I'll touch upon ways that the retail industry has been impacted by the coronavirus as well. So a little bit about myself. Again, as I mentioned, I'm the CEO of Boldmetrics, and we service the apparel industry. We have a technology that is based on AI to predict the body measurements of consumers in an algorithmic way, and then take those body measurement predictions to create sizing recommendations for apparel products, as well as drive insights for apparel manufacturers and designers to take a data-driven approach to product design. Now, I have 10 plus years of experience in developing technology companies that have been based on and focused around AI and machine learning. And this is predominantly because my background is in engineering and data science. Prior to Boldmetrics, I was in academia for a number of years, doing research within the biophysics and optical imaging space at MIT and UCLA. And then through those experiences, I've published more than 7 articles in academic research journals, as well as patented technology within that space. So to start off my presentation, I wanted to give a brief overview of what artificial intelligence is, and give examples by the different cognitive domains within that space. So artificial intelligence in general broadly applies to any technology that is mimicking human behavior, usually by creating algorithms that make decisions and make predictions based off of the way that it's trained based on the data. There are various cognitive domains within the AI space, and I've reviewed 5 of them here. And there's, of course, can be much more than that, but this is perhaps the more dominant 5 cognitive domains. So we have machine learning, which many of us have heard before, and this encompasses various ways to take data, train on it, and create predictions. So different approaches include supervised learning, unsupervised learning, reinforcement learning, and then more recently gaining popularity of deep learning and neural networks. And so some of the applications downstream that we're familiar with is recommendation engines like Netflix that use this type of approach to machine learning and AI. And then we also have robotics. Robotics is another cognitive domain of artificial intelligence that uses ways to train machines to physically manipulate things, take information from sensor data, and provide autonomous navigation, things like that. So AI-based robotics are often used in warehouse robotics and shipping. Rule-based AI and decision trees is another form or cognitive domain of AI that learns ontologies and applies logic on those ontologies. And then natural language processing is another cognitive domain of AI that uses text processing, speech recognition to formulate decisions. And so we're familiar with Amazon Alexa or Siri, and these use NLP algorithms to follow those approaches. And then computer vision is another area of AI that takes information from images or from video and parses that data down. So automatic driving like Tesla is heavily based on computer vision. So this is not to say that any of these cognitive domains are mutually exclusive. So usually one area will encompass other areas as well. So in computer vision uses a lot of components of machine learning, and natural language processing also uses machine learning. So it's not to say that they're mutually exclusive, but in general, this is how you can kind of think of the cognitive domains of AI. So for the purpose of the presentation today, I wanted to have a specific focus on machine learning and the applications in the retail industry itself. And so I'll go through these 4 different types of machine learning and just broadly cover them and give some examples on how it's used within the retail industry. And then I'll move into how the coronavirus has impacted the retail industry and some specific problems around that as it relates to what my company is doing. So to start, we'll review supervised learning. So supervised learning is a form of machine learning that is very task-driven. So it requires a labeled data set to train the algorithms. So what that basically means is you know what the labels are, what the data represents. And then you also indicate to the algorithms what you want the output to be. So supervised learning works really well when you know what your inputs are and you know what your outputs are. and then create an algorithm that can take those inputs and learn off the data to create outputs that are predicted in the future. So then, in a situation where you have new data input into the system, it can predict the outputs. In the retail industry, specific examples that use this type of machine learning approach are things like predicting inventory needs. So exploiting purchase data to predict inventory needs based on the day of the week, the season, nearby events, social media data, and consumer behavior from the past. And then demand forecasting for certain products often uses machine learning algorithms as well. And then predicting consumer behavior, estimating how buyers will behave in the future based on previous behaviors. So these are just some of the examples within the retail industry, particularly on the e-commerce space, that use this approach to machine learning. Unsupervised learning is more of a data-driven approach where you, in a case where you don't know what your labeled data inputs are in your training set, so you don't necessarily know what the specific labeled points are in the data that you're training your algorithms are, and you don't necessarily know what the exact kind of output that you want. So without labeled data, you would use an unsupervised learning approach, and this essentially is an approach to identify trends in the data and can cluster and based on these trends, cluster the data together to produce outputs that would be interesting that extrapolate information from those trends. And so in the retail industry, in the e-commerce space specifically, some things that we might be familiar with is when you're browsing on a product display page and you see that a section that says customers also like, and it shows you recommended products to you based on what other people have looked at. So this is typically an unsupervised learning approach to show you the similar products that other customers have looked at. Any kind of personalization and recommendation engine that's based on your past browsing history is usually using unsupervised learning to come up with those clusters and those trends. Targeted advertising, so smart advertising that captures like customer interest and past browsing history tends to use unsupervised learning algorithms, as well as product matching, styling outfits or finding similarly grouped products and grouping these together to provide that information to the consumer. And then we have reinforcement learning. So this is an approach to machine learning that allows algorithms to learn from mistakes. So you'll have a situation where your environment provides feedback where when an action is taken, it's either rewarded or indicated as a mistake, and then that information changes the state that is provided to the agent, which then takes a corrected action in the algorithm so that the environment is then adjusted based on this reward or mistake behavior. And so this type of learning is pretty commonly used in dynamic pricing models. So when a retail site wants to adjust pricing in real time based on a consumer's response to offers, and reinforcement learning is a great approach to try to obtain these types of dynamic pricing models. Fraud detection and identifying fraudulent purchases often use some element of reinforcement learning, as well as optimization of merchandise planning. And then finally, we have neural networks. Neural networks has become more popular in recent years due to better computing power. And essentially, it's something that most closely mimics the human brain and allows algorithms to learn upon themselves. Most of the applications that I've already discussed in retail industry, neural networks can be applied to it. And then it's a great approach to identify additional feature extractions in an automatic way, as opposed to being defined up front by the in the training algorithms. And so, but this approach typically has a data threshold. You do need a lot of data in order to build neural networks on it. So that's typically can infer whether or not you can go with an approach like neural networks or a traditional machine learning approach. But there's great advantages to it. They are often more capable of identifying additional characteristics and trends in the data that weren't identified using traditional machine learning. And oftentimes it can be found that they can yield improved prediction accuracy than, say, like a supervised learning approach in general. So now that you know the various kinds of, like an overview of the different machine learning approaches and subdomains of machine learning, I wanted to drill into a little bit more into the retail industry and its general adoption of AI and ML. So to start with, we'll compare the retail industry across a number of other industries. And so comparatively, how is AI being adopted across industries? So on the left-hand side, you can see telecom, high-tech, financial services, professional services, electric power, healthcare, automotive industry, travel, in pharmaceutical as well as retail, and how all of these industries adopt different AI approaches, including within business functions of service operations, product or service development, marketing and sales, supply chain management, manufacturing risk, human resources, and strategy. And so overall, all of these industries have adopted AI in some way, shape, or form. Most of them more towards the service, product design, marketing, and sales side. If we look at retail specifically, which I have highlighted here, you can see that most of the adoption of AI within this industry is in marketing and sales, which makes a lot of sense. A lot of ML approaches are being applied to increase conversions and drive increased sales, as well as some adoption within supply chain management, as well as service operations. What I find interesting is how it's under-indexed in the product design area of AI adoption, which will make more sense when you learn a little bit more about what Boldmetrics does later in this presentation. So if we look more specifically at ML applications within the retail industry itself globally, and this data is from 2019, we can see that the adoption rate has been the highest in areas of consumer engagement, so at 45%. And again, that makes sense in driving conversions, increasing sales, but also has seen a lot of adoption within the supply chain logistics and management, supply and demand prediction, payment processing, product recommendation engines, which we reviewed, and the various ML approaches that can be used to create recommendations. And then again, only less than 20% in product design and creation. So we'll transition now to talk a little bit about how the coronavirus has created change in the world as we know it. So it's been shown more recently that with the onset of COVID-19, there's been an acceleration of consumer digital adoption within the U.S. So U.S. consumers are using digital channels for their various needs across industries, more so than ever before, at an unprecedented rate of increase. So this includes increased first-time users within the digital channels within banking, entertainment, grocery, apparel, utilities, telecom, travel, and insurance. And so if we look specifically at apparel, prior to COVID, about 31% of U.S. consumers were regular users of digital channels, the various digital channels to meet their apparel consumer needs. And then with the onset of coronavirus, there's been an unprecedented 13% increase in the use of digital channels within the apparel industry alone. And so now we see an overall 45% adoption of digital channels for apparel. So this has really been quite an interesting phenomenon to track within these various industries and within apparel and retail itself. So how is COVID-19 changing retail? Well, a recent study that was done by BizRate Insights this year has found that the top priority for consumers within the U.S. is their concern around health and safety. So they would be willing to go to a brick and mortar store in person if they were to be convinced that the store was having adopted some visible health and safety measures to keep the consumer safe. And 55% of respondents within this 1,000-person survey indicated that concern. And also what's been we've been seeing within the retail industry is a broad adoption of curbside pickup. So contactless pickup, being able to purchase your items online and then going to the store, but just picking it up curbside. Rather than going inside the store. And there's been an 86% increase in this type of purchase model for retail, with 32% of shoppers saying that they would use this type of method. So that's been quite interesting to see. There's also been a massive increase in buying products online. So a 60% increase in online purchasing, as I mentioned, more people are starting to adopt digital channels. And we're seeing more spending on multi-brand retail sites like Amazon, with a 32% increase there. And then 64% of consumers are more likely to consider alternative methods to traditional in-store shopping or brick and mortar shopping as a result of the coronavirus. And this has a lot to do with the safety concerns. And so with a 64% increase and 60% shopping online, certainly the retail industry is seeing these changes. And retailers are facing these changes across multiple dimensions. McKinsey found that we have covered a decade and days of adoption of digital driving massive AI acceleration practices across the retail industry, which has been really interesting to observe how fast all these industries are adopting in response to the pandemic. Retailers have to reinvent the shopping experience, create hassle-free shopping in a high hygiene environment, change store layouts, reconfigure their checkout, all while recognizing the fact that they're seeing a 15% drop in consumption overall industry-wide, and then take a leapfrog of digital capabilities towards first-class e-commerce experiences and seamless omni-channel experiences. And so it's been a lot of change within the retail industry to recognize this. And so that's really brought us to our new normal. Contactless curbside pickups. And then with stores being a contactless curbside, when they do eventually open, what we are finding in the US is the fitting rooms are closed, so people aren't able to use the fitting rooms to try on clothes. So when you're considering the apparel industry, there's ramifications associated with not being able to interact and try on the garments. And then also this major shift towards online shopping and increased dependence on the retail industry to rely on their e-commerce sales to drive their business. So now there's specific ways that the specific challenges that the apparel industry faces in this new normal. And if we look at the apparel industry in the context of return rates, we see that pre-coronavirus, online return rates were really high. So at an industry average of typically 30% when a apparel product is purchased online is returned. That's a huge percentage. And often some retailers suffer as high as 50% of their apparel products being returned that are purchased when the purchase is made online. So imagine half of your products that are purchased online are returned. This creates a huge problem for sustainability and general global footprint that a brand has on the environment. So if we look at the in-store clothing purchases, the return rate is far less. It's around 10%. And however, with the change in our new normal, with curbside pickups and dressing rooms being closed, we can expect that 10% is going to increase dramatically, and most likely will be more closer to that of the return rate of online purchases being around 30%. So what drives returns in the apparel sector? Well, the most common reason for someone to return an online order is issues with fit. So a study recently done by Narvar last year with over 3,000 participants found that 46% of the time that an online purchase is returned is because of some problem associated with fit. And so this is the driving factor that's causing returns. And I think it's just going to get a lot worse with the in-store fitting experience not being available to consumers when they go in a brick and mortar store. And there's a significant need in general for sizing guidance in store, as well as fitting optimization strategies online. The current overall strategy for apparel retailers online is to provide size charts. And a size chart is essentially a description of your body measurements in each size. Most people do not know their detailed body measurements, so it's not a very helpful guidance system for consumers to understand which size is going to fit their body. And then beyond consumers' size confusion, apparel manufacturers face challenges in designing the right sizes to begin with. So in the apparel industry, for ready-to-wear sizing design, the apparel dimensions are designed based on very limited information. So typically what they do is identify a fit model that they think would fit their brand and would represent a size medium. And then they will design the dimensions of their garments to fit that fit model, or a dress form, which is basically a mannequin with the body measurements. And then design your size or two sizes to fit these set measurements, and then scale proportionally to define the higher and lower sizes. And so there's very limited information that goes into the apparel design process, and as a result, apparel manufacturers are designing clothing that's not necessarily using the data of their consumer's body. So it also creates ill-fitting garments from inception. So you have the higher potential for ill-fitting garments to reach the market, and then you have very little sizing guidance downstream when the consumers are making their purchase decisions. And so at Bold Metrics, we think that scalable 3D body measurement capture holds the solution to the issue of returns. So we see a future where customer body data and AI aid consumer purchases both in-store and online. And in this future, consumer body measurements will drive deep insights within product design and apparel sizing. So how are companies acquiring customer body measurement data today? The most traditional method has been to install a body scanner within stores. So this is a hardware device that lives on in a brick and mortar store that people would step into and get scanned. Typically they have to wear tight-fitted clothing or underwear to have the accuracy high. Clearly there is not a lot of scalability in this approach because it involves installing scanners in all your stores. So more recently, companies have tried using the concept of taking a selfie and using our smartphone devices or our webcam to take photos of ourselves and generate the body measurements based on that photo. So this type of approach suffers from low accuracy because you have to wear tight-fitted clothing. There's a lot of ways that to introduce human error for the consumer to not exactly take the photo correctly. And so as a result, the accuracy typically suffers. And also it just is not as practical for online and in-store purchases because it requires the consumer to do a little bit too much. So it's a lot for a consumer to do in order to make a purchase. So at Bold Metrics, what we've done is taken a machine learning approach. So apply machine learning in a way to algorithmically predict body measurements. And then this creates accurate body measurements and scales really well. And we've done this through years of machine learning with tens of millions of data points. So we started in 2012 collecting body scan data. And based off of this rich data source that we've continually collected over the years, we can then create machine learning models that can take very basic inputs and then predict detailed body measurements on a customer algorithmically. So instead of someone stepping into a body scanner, they're now doing it by just answering simple questions. And we've tested the accuracy of our body measurement predictions hundreds of times with custom clothiers globally that have found our predictions to be very accurate, and since then started working with mid-tier and Fortune 500 brands and retailers so that we can generate our body measurement predictions and predict size recommendations as a sizing guidance system for online and in-store purchases. And the results have been tremendous. We have highly accurate body measurement predictions, so we're typically within 3% of a master tailor or a body scanned measurement. And on average, our technology can reduce returns by 32%. For our clients. And then we also see a conversion lift depending on where the technology is incorporated. On average, though, the conversion lift can be 40%. So a little bit about how it works. So again, we predict consumer body measurements based on very simple inputs. So we display usually 4 to 6 inputs somewhere within the consumer journey, whether in-store or online. And the shopper answers these questions. These then are sent to our algorithms, our machine learning algorithms, that then predict over 50 body measurements on that consumer. And as I mentioned, the body measurements are highly accurate, as we've done countless studies to compare our measurements to a master tailor or a body scanned measurement, and it's within about 3% of the true measurement. We then connect this to ready-to-wear sizing by taking the body measurements that are predicted and connect that to the information about the garment, whether it be the garment dimensions or the technical specifications of that garment, to start to understand how that garment would fit across your specific body measurements, and generating a fit score that provides the consumer an overall understanding of what their best size is and how it would fit across their critical points of measure. For anyone that goes through our system, essentially what we do is collect the purchase and returns data on those customers so that the machine learning algorithms can continue to improve over time and start to understand how to correct when a mistake was made, and also start to understand which styles of garments aren't fitting consumers correctly. Some of these insights can be used within product design and create generally better recommendations over time. On the front end, consumers can see this in a sort of like a two-dimensional overview on how the garment would fit across the critical points of measure for that specific garment. So this is an example where a person's being recommended a size small as their best size, but they might find it be a little bit snug on their stomach area and just right in the other places. But if someone is maybe self-conscious about their stomach area, they might choose to move up a size and see how that would fit. In a size medium, they can see it's just right around my stomach, and maybe I'm okay with it being slightly loose in other areas. So this type of approach really allows to show the fit across the body and for a consumer to take their own subjective fit preference when making their purchase decisions. We can take it a step further and provide 3D avatar virtualization for virtual dressing room implementations. So whether in-store or online, if an apparel brand wants to have their consumers visualize how they would look in the garment on a avatar that's representative of their body, we can support that. This allows the consumer to then see the product on their 3D avatar, to compare different sizes on how the fit would change based on size, and to even show a comfort map to see the fit with a visual representation of color, indicating what places are tight and what places are loose. And then finally, to address the needs of our new normal in the coronavirus era, our contactless fit solution can be integrated in the in-store environment. So in places and in stores where the dressing room is no longer available for consumers, or consumers have concerns around their own health and safety, they can use our contactless fit solution, whether it be integrated in store on the iPads, on a touchscreen display, or through their own smartphones. They can start to understand and contextualize the fit across their body on a particular garment that they're looking at in store, and simulate that dressing room experience digitally. And of course, this type of product can be integrated with contactless pickup options and payment solutions, as well as connect to the inventory management systems for that store. And then finally, anytime a person goes through our technology, they're being effectively digitally body scanned. So they're being algorithmically body scanned, and we understand their detailed body measurements and how that relates to the product that they were looking to purchase or that they made a purchase on. And so all of this information could drive deep insights to improve the product design cycle for the apparel manufacturers. So apparel manufacturers and brands can start to obtain consumer body morphology analytics. They have access to the consumer body measurements and the avatars and the detailed body measurements of their specific customer. And this information can be used within 3D design and product design to take a more data-driven approach to sizing specification design, as well as understand how their returns are performing based on the body measurements of their consumers. Is there certain garments that weren't designed well and are driving higher returns because it doesn't fit their customers very well? So this ultimately is in an effort to create this cyclical model of data flow within apparel sizing as a way to, in the downstream sales component, be able to provide sizing guidance for the consumer and predict their body measurements and have them know what size is best for them, but then be able to drive this information upstream within sizing and product design to create better fitting products. So with accelerated market adoption, broadened data capture methods, more data variety, and increased computing power, AI will certainly make a long-lasting impact in our retail experiences, certainly now and definitely in the future as we cope with the pandemic. So thank you very much for your time and listening to me, and I do encourage you to reach out if you would like to follow up with any questions. You can reach me at contact@boldmetrics.com. Thank you so much.